Okay, so this question is asking you to solve for this side of the triangle. And what you solved for, correctly actually, was this side of the triangle. So you just needed to take it one step further. So you solved for this value right here. And I'm just going to call that side B. So you can only use the Pythagorean theorem if you are given a right triangle. So we have our hypotenuse here, 8 squared is equal to b squared plus 6 squared. So 64 is equal to 36 plus b squared. B squared is equal to 28, and b is equal to the square root of 28. So you solved for this correctly, but what you really needed was this side of the triangle. So you needed to go ahead and take this answer, which square root of 28 was equal to 5 point, let's see, I just need to grab my calculator real quick. So 5.29. So you did solve for this side, but that's not what the question was asking for. So what you need to do now to regain some points from this is to take this information, b is equal to 5.29, and now solve for this side of the triangle using the Pythagorean theorem. And this time let this value be, say, x. So you're going to set up the equation. X squared is equal to 3 squared plus 5.29 squared. So then you would go ahead and solve that for x, and that would answer that question. So this question asks you to calculate the altitude of an equilateral triangle with a perimeter of 30. So if you have an equilateral triangle, that means all the sides are equal. So if all the sides are equal, and your perimeter is 30, remember perimeter is distance around the triangle, that means each side is equivalent to 10. But the altitude is asking you to find this line right here that's going to, because it's an equilateral triangle, pretend that's a little right angle I have going on there, but because it's an equilateral triangle, we know that it is going to, your altitude is going to split the base in half. So that's 5. It's asking you to calculate this value right here. So again, you're going to be using the Pythagorean theorem. Oops, that's kind of rough. You're going to be using the Pythagorean theorem for this right triangle right here. So I'm just pulling this triangle out. So we have a side of 5 here, a side of 10 here, and you're solving for x. So again, you're going to set that up as 10 squared is equal to x squared plus 5 squared. You're going to go ahead and solve that equation for x. All right, so on this one, this is asking you to find the perimeter. But this value of 12 that they are giving you, they're giving you the altitude of the triangle. So they're giving you this value right here, where that's equivalent to 12. And they're telling you that the entire base is 5, so half of the base is 2.5. Now, technically, we shouldn't just assume that this altitude cuts it in half. They should have told us that it's an isosceles triangle, but we're going to go ahead and make that assumption because it says select the best answer from the choices below. So to calculate the perimeter, you need to know what these sides are equal to. So again, you have this right triangle going on. So I'm pulling out just half of it. So we have this right triangle going on where we have 12, 2.5, and x. So you would use, again, the Pythagorean theorem. This is your hypotenuse, is equal to 12 squared plus 2.5 squared. and you would solve that for x. But the perimeter means that you need to add up the lengths of all three sides. So once you solve for x here, you would have that value of x plus whatever this value of x is, obviously they're the same, plus 5. And that would give you your total perimeter. Okay, this is that you need to write your answer to two significant figures. So you would go ahead and take 0.5 cubed, plug it into a calculator, and it is going to give you 0.13, possibly repeating. Let me double check that. So 0.5 raised to the power of 3. And sorry, it actually gives you 0.125. But the question only wants three significant figures. So that could be written as 0.013. All right. So this one, for this one, I'm going to refer you back to the video I created this weekend for you on how to define inequalities, because it goes over this type problem. But I did want to mention, when you're finding the equation of a line, I'm just going to do one of these for you, and then I'm going to leave it to you for the other two. You want to start by putting these equations in y equals slope-intercept form, where you identify the slope and the y-intercept. So the y-intercept is where this line crosses the y-axis. So you can see that this one, I'm going to go ahead and define this line right here. It crosses the y-axis at 1, 2, 3. So that means my y-intercept is 3. But we also need to identify our slope, or our rate of change. So to do that, I'm just going to pick 2 points on the graph and find my slope. So remember, slope is change in y over change in x, also known as rise over run. You could also find it by using this nifty little x2 minus x1 formula divided by y2 minus y1. But it's just as easy to look at whether or not your slope's positive. So it is, because this line is increasing. And we have a rise of 2 and a run of 2. So that gives you a slope of 1. So y equals x plus 3. But you see this is a dashed line. So it's not actually a y equals line. That is a y is, and then that's where your shading comes into play. See how we are shading below this line. So to shade below this line, that would be y is less than x plus 3. So that equation would go with this line right here. And I just want to give you a little hint on this one. When you have a horizontal line, everywhere on that line, your y value is 8. So your y value is staying the same, but your x value is changing. So that is actually a y equals line, not an x equals line. So that's going to be a y equals line. Okay, and again, for further guidance on this one, please go back to the recording that I did on this weekend to help with this one. Okay, so 13 says the short leg of a right triangle. So we're going to go ahead and just draw a right triangle. Let's see, so we can really see that we've got a short leg. The short leg of a right triangle is 6 meters shorter than the longer leg. So we're going to call the longer leg x. This shorter leg is 6 meters shorter than x, so we're going to call that x minus 6. It says the hypotenuse is 6 meters longer than the longer leg. So it's 6 meters longer than this. So we would call that x plus 6. So now it wants us to find the side lengths of the triangle. So that means we need to solve this using the Pythagorean theorem and a little bit of algebra. So remember your hypotenuse squared, so x plus 6 squared is equal to x squared plus x minus 6 squared. So you want to solve this equation for x. And so I'm going to go ahead and do this one for you, but to regain a few points from this, I can give you one similar to this for you to try. So I'm going to go ahead and expand x plus 6 squared. So that's going to give me x squared plus 12x plus 36 is equal to, so what I did here is I used the distributive property. I did x plus 6 times x plus 6. So x times x, x squared, 6x plus 6x plus 6 times 6, 36. Now that is equal to x squared. I'm going to do the same thing to expand this. So that's going to give me plus another x squared. This time I'm going to have a negative 6x plus a negative 6x, so minus 12x plus 36. So now it looks like I have a lot of fun. Pretty big equation to simplify, but once we start adding like terms, it doesn't look quite as bad. So that's going to give me x squared plus 12x plus 36 is equal to 2x squared minus 12x plus 36. So I'm going to start by grouping everything on one side and setting this equation equal to 0. So I'm going to subtract 36 from both sides. That's nice, that zeroes out. I'm going to go ahead and subtract 12x from this side. So that's going to give me negative 24x. Remember, that's already gone to 0. We still have this 2x squared, and we have this x squared. So we want one side equal to 0, so I'm just going to subtract this x squared over here. So, I'm running out a little bit of space. That's going to give me 2x squared minus 1x squared is x squared minus 24x is equal to 0. So now I want to solve this quadratic. I can solve this by factoring. So I have an x times x minus 24. So I have two values of x that would make this solution true. One would be x is equal to 0, which we know can't be true because we are dealing with an actual triangle distance here. Or we could have what minus 24 will give you 0. Well, that would be 24. So x would be equal to 24, which means this leg would be equal to 30, which means this leg would be equal to 24 minus 6, which is 18. So to check, to make certain that we did this correctly, this should satisfy the Pythagorean theorem. So 30 squared should be equal to 24 squared plus 18 squared. Well, we know 30 squared is 30 times 30, which is 900. And we know 24 squared is equal to 576. And 18 squared is equal to 324. And 576 plus 324 is equal to 900. So, yep, we know we did this correctly. So if you'd like to try another one similar to this, feel free to. And you can go ahead and change this to 8. Change that value to 8. And then work through the same process.